Okay, let's go. Number 1. The shielded zone of the moon. 238,000 miles from Earth, there is a stretch of ground that has never once picked up a signal from home, not a radio broadcast, not a satellite ping, not a stray bar of cell service. That absence exists because an international body spent decades trying to keep it that way on purpose. The moon is tidally locked, so the same face always points toward Earth and the far side always points away. That far side sits behind more than 2,000 miles of solid rock, which blocks every transmitter, every satellite signal, every bit of the electromagnetic noise the planet constantly leaks into space. It is the quietest patch of radio spectrum inside the entire solar system, and it came about by accident of orbital mechanics long before anyone thought to protect it. NASA learned exactly how absolute that silence is decades ago. During Apollo 8, every time the spacecraft swung behind the moon, Mission Control lost all contact for about 45 minutes. No radio, no telemetry, nothing, until the capsule came back around the near side. More than 50 years later, NASA is planning for the same 40-minute blackout on Artemis crews flying the identical orbit. Not a communications failure, simply what the far side does to a signal, every time, without exception. China ran directly into the same wall in January of 2019, when its Chang'e 4 lander became the first spacecraft in history to actually touch down on the far side, inside von Karman crater. Direct contact with Earth from that spot is not merely difficult. It is physically impossible, so China had to launch a separate relay satellite, Queqiao, into an orbit far beyond the moon just to bounce a signal between the lander and home. There is no shortcut around the shielding. There never has been. What nobody outside radio astronomy fully appreciated until 1971 was that this same silence could be legally protected rather than just endured. That year, the International Telecommunication Union's World Administrative Radio Conference formally defined something called the shielded zone of the moon, a designated region where radio transmission is restricted specifically so that future telescopes built there could listen to the universe without Earth's own noise drowning everything out. Engineers pushing lunar telescope projects have kept fighting to protect it decades later, because it remains the only naturally silent room left in the solar system. More recently, scientists have proposed something called the Protected Antipode Circle, a patch of the far side roughly 1,130 miles across, centered near a crater called Daedalus, and they want the United Nations to formally recognize it as an internationally protected, radio contamination-free zone. The target is a specific period of the universe's history, called the Cosmic Dark Ages, the stretch of time before the first stars switched on, when the only trace left behind is a radio signal so faint that Earth's own background noise buries it completely. That is not a small ambition. No permanent settlement has been built there. No company has staked a claim there. The entire proposal exists to protect a silence humans did not create and, so far, have not managed to ruin. This same instinct, protecting the darkness itself so the science can still be done, appears again on the very next stop on this list. Except that time, the darkness was not being protected from noise. It was being watched, closely, for a flash nobody wanted the world to see. Number 2. The Vela Incident. On September 22, 1979, an American satellite called Vela 6911 recorded exactly the signal it had been built to catch, a double flash of light over the Indian Ocean near the Prince Edward Islands, roughly midway between Africa and Antarctica. That double flash is the specific optical signature of a nuclear detonation, and Vela 6911 existed for one purpose: to watch dark space and the surface of the Earth for exactly that signature, so no nation could test a nuclear weapon in secret. The satellites were not a one-off. The Vela Hotel program had been launching detection satellites in pairs since 1963, days after the Limited Nuclear Test Ban Treaty was signed, specifically to give the United States its own independent way to verify that the Soviet Union and everyone else was actually keeping the promise that treaty made. By 1979, the network had become part of what the Department of Defense still calls the Nuclear Detonation Detection System, quietly watching the sky and the ocean for the one signature that mattered. The satellite worked exactly as designed. What happened after it worked is the actual mystery. A White House panel, chaired by MIT professor Jack Ruina, examined the data and concluded the flash was probably not a nuclear test at all, suggesting instead that a small meteoroid might have struck the satellite and produced a false signal. The Central Intelligence Agency reached a different conclusion. Its own internal assessment put the probability of a real nuclear detonation at 90% or higher. That gap has never been fully resolved, between what the White House said in public and what its own intelligence service believed in private. Both cannot be the honest best guess of the same government at the same time, and only one of them has ever been treated as the official answer. Researchers and former officials have kept returning to the question for decades since, including at a critical oral history conference that gathered participants from the time to compare notes on what they actually knew and when they knew it. Newer analysis has narrowed the mystery considerably. Scientists studying the declassified hydroacoustic and radionuclide data alongside the original satellite readings have built a strong case that the event really was an undeclared nuclear test, widely attributed to Israel, carried out with South African assistance. 45 years later, part of the American intelligence file on the incident remains classified, and no U.S. administration has ever formally confirmed what its own analysts privately believed at the time. That is the kind of gap between the story a government tells the public and the file it keeps sealed that tends to repeat itself. Watching the dark for one kind of signal, in this case, a weapon test nobody wanted acknowledged, is one version of a forbidden search. An entirely different kind of watching, aimed at a very different kind of signal, would soon get built, funded, mocked, and ultimately defunded, in full public view. Number 3. NASA's SETI program. Senator William Proxmire once handed NASA something called the Golden Fleece Award, his own personal prize for what he considered the most wasteful use of taxpayer money he could find that month. The program he chose to mock was NASA's radio search for extraterrestrial intelligence, a project built to listen into the darkness of space for any trace of an intelligent signal, and the ridicule began almost as soon as the program did in 1971. For 2 decades, NASA's SETI researchers kept working regardless, building the case, refining the equipment, publishing the science, until in 1992 they finally secured a real budget, $100 million over 10 years, enough to run an actual, sustained radio search across the sky. That was not even the part that provoked the most anger. 1 year later, on the floor of the Senate, Nevada's Richard Bryan introduced an amendment killing the entire program outright, and he did not soften the language. He told his colleagues, quote, "Not a single Martian has said, 'Take me to your leader,' and not a single flying saucer has applied for FAA approval," end quote, and called the whole effort the Great Martian Chase at the taxpayers' expense. Congress laughed along and agreed with him. A fully funded, peer-reviewed federal research program searching dark space for evidence of intelligent life was defunded because it sounded embarrassing on the Senate floor. Researchers in the field have a name for what killed it: the giggle factor. Not a lack of evidence, not a failed experiment. A reflex, in Congress and in plenty of newsrooms, to treat the search itself as a punchline, tangled up with decades of little green men jokes the actual scientists had nothing to do with. The program that was cut was not some fringe side project either. NASA's high-resolution microwave survey ran 2 coordinated searches at once, a targeted scan of nearby sun-like stars and a full survey of the entire sky, built and reviewed by working astronomers the same way any other federally funded research is approved. Anyone who has found this list worth their time so far should subscribe now, because what comes up 2 spots ahead is stranger than anything Congress ever voted on. The program did not actually die in 1993, it only changed its funding source. Microsoft's Paul Allen and Intel's Gordon Moore stepped in with private money almost immediately, and by 1995 the SETI Institute had revived the search under a new name, Project Phoenix, funded entirely outside the federal budget. 2 decades later, in January of 2016, technology entrepreneur Yuri Milner launched Breakthrough Listen, a $100 million privately funded search based out of UC Berkeley, running on telescope time NASA itself was never again allowed to pay for. The science had not grown any less interesting. It had simply become politically radioactive to fund with tax dollars. Everything about Congress, killing that program in 1993, had worked against those who wanted to keep listening. What almost nobody has heard of is a separate rule those same scientists wrote for themselves, covering the one outcome the funding fight never actually addressed. What happens the day the search finally works? Number 4. The SETI Post-Detection Protocol. In 1989, a committee inside the International Academy of Astronautics wrote a document almost nobody outside professional radio astronomy has ever read, And it answers a question that sounds like science fiction: what a scientist is actually supposed to do the moment a real signal from another civilization comes through. The document is called the Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence. It lays out a specific sequence. Whoever finds a candidate signal must first verify it using at least one independent observatory before saying anything in public. Once confirmed, the discoverer must inform the Secretary General of the United Nations, along with the rest of the scientific community, in a full and complete manner. Only after that does the document reach its most consequential line. Its own text states, quote, "No response to a signal or other evidence of extraterrestrial intelligence should be sent until appropriate international consultations have taken place." End quote. The obvious problem is what appropriate international consultations would even look like in practice, and the honest answer is that nobody fully knows, because the rule has never once been tested against a real detection. The closest anyone has come happened years before the protocol even existed. On August 15th, 1977, Ohio State's Big Ear radio telescope picked up a 72-second signal from the direction of Sagittarius, so strong and so clean that the astronomer reviewing the printout circled it in red ink and wrote a single word in the margin: "Wow." Nearly 50 years later, despite repeated searches of that exact patch of sky, nobody has ever detected it again, and no verification protocol existed at the time to tell anyone what should have happened next. A supplemental draft covering exactly how a reply might be handled followed in 1995, and both documents were formally presented to the United Nations Committee on the Peaceful Uses of Outer Space in the year 2000. The full declaration was revised again in 2010, and in June of this year, the same committee, led by a team at the University of Manchester, announced its first major update in more than 15 years. Built specifically to account for social media and AI-generated misinformation in the middle of a real detection event. Decades of committee work, 3 international presentations across more than 3 decades, and one clear instruction sit behind this rule, and none of it carries the force of law anywhere on Earth. That detail changes everything about how seriously to take it. If a radio telescope detected a confirmed signal tomorrow, the scientists who found it would be bound by nothing but their own professional agreement not to reply without asking the rest of the planet first, and any government, company, or private individual with a large enough dish would remain free to answer anyway. The scientists who wrote that protocol were not trying to prevent contact. They were trying to prevent one lab, one country, or one person from deciding, alone, how humanity introduces itself to whatever might be listening. Whether that restraint would survive contact with an actual signal has never been anything but a theoretical question, right up until the moment a very different kind of restraint gets tested against something people were far more certain they understood. Number 5. The LHC Black Hole Lawsuit. In March of 2008, months before the Large Hadron Collider had even been switched on, a retired nuclear safety officer named Walter Wagner and a Spanish science writer named Luis Sancho walked into a federal courthouse in Honolulu and asked a judge to stop it. Their argument was specific. The LHC was designed to smash protons together at energies no machine on Earth had ever reached, and Wagner and Sancho argued that CERN had not adequately ruled out the possibility that a collision could create a stable, microscopic black hole, or a hypothetical form of matter called a strangelet, either of which, in the worst case they described, could begin consuming the planet from the inside out. This is where the story takes a turn few expected from a lawsuit about physics. A federal judge actually held a hearing on it. The government asked for the case to be dismissed, and in September of 2008 the judge agreed, ruling that the plaintiffs had failed to show a credible threat of harm. Wagner appealed. The case was dismissed again, this time on a different technicality, since CERN is owned and controlled by its European member states, and the United States holds only observer status on its governing council. An American court had no real authority over the machine at all. The fight did not stay confined to Hawaii either. A German chemistry professor named Otto Rossler calculated that black holes produced inside the LHC could grow exponentially, and put an actual number on his fear, estimating the world could end a little more than 5 years after the collider first reached full energy collisions. Rossler and a group of professors and students, mostly from Germany and Austria, brought their case to the European Court of Human Rights in Strasbourg, France, the same court that hears genuine human rights violations. The court agreed to review the doomsday claims. It ultimately declined to order an immediate halt to the collider's operation. CERN did not simply dismiss the concern either. In 2007, before the LHC ever switched on, CERN convened its own LHC Safety Assessment Group, 5 physicists with no role in the collider's actual experiments, to formally evaluate every version of the black hole fear on the record. When Rossler met directly with a CERN physicist to walk through his math, the physicist asked a separate outside expert, the director of the Albert Einstein Institute in Germany, to independently check the calculations. That review found what it called logical inconsistencies and physical misunderstandings in Rossler's argument. The Safety Assessment Group's own report, issued in June of 2008, concluded there was no basis for any concern about the consequences of new particles or forms of matter the LHC could possibly produce. The Large Hadron Collider switched on anyway. It has been running for well over a decade, producing some of the most important physics results in a generation, including confirmation of the Higgs boson, without swallowing anything. But the lawsuit remains a real, documented fact regardless of the outcome. A court in Hawaii and a human rights tribunal in France both spent public time formally weighing whether humanity should be legally forbidden from manufacturing the exact kind of object that swallows light for good. That fear turned out to be unfounded, but the willingness to sue over an imagined danger in a laboratory is nothing next to what one government actually did, on purpose, with a real nuclear weapon, in space itself, decades before anyone had heard of the Large Hadron Collider. Number 6. Starfish Prime. On July 9, 1962, 250 miles above the Pacific Ocean, the United States detonated a 1.4 megaton nuclear warhead, the largest nuclear test ever conducted in space, in an operation called Starfish Prime. Nobody watching from Hawaii, 900 miles away, was prepared for what they saw. The sky itself lit up green and red for several minutes, an artificial aurora bright enough to read a newspaper by, visible across a huge stretch of the Pacific. That part made the newspapers. What did not receive nearly as much attention at the time was what the blast did to the space around it. The detonation released a pulse of high-energy electrons that Earth's own magnetic field caught and trapped, forming a new radiation belt around the planet that scientists had not predicted and did not expect to last. It lasted for months. Within weeks, that radiation pulse had damaged or destroyed at least 6 satellites, including a Soviet one, and every one of them eventually failed because of it. That was only the first round. Telstar, the world's first commercial telecommunications satellite, the one that carried the first live transatlantic television signal, launched into orbit the very next day. It absorbed radiation from Starfish Prime almost immediately, and its systems began failing within months, permanently damaged by a bomb the United States had detonated the day before Telstar even reached space. And the story only grows worse from there. That artificial radiation belt did not fade within days or weeks. Researchers tracking it found elevated radiation lingering for years afterward, by some estimates the better part of a decade, before it finally faded back toward normal. Starfish Prime was not even an isolated test. The Soviet Union was running its own high-altitude nuclear detonations at the same time under a program called Project K, and on October 22, 1962, in the middle of the Cuban Missile Crisis, a Soviet 300-kiloton warhead detonated high above Kazakhstan and knocked out phone lines and power cables hundreds of miles away with its electromagnetic pulse. The Soviet K-series ran 5 high-altitude shots in total between 1961 and 1962, the first 2 relatively small at just over a kiloton each, the final 3 around 300 kilotons apiece. 2 nuclear powers were detonating high-altitude weapons, while the rest of the world focused on a nuclear war nearly breaking out over Cuba instead. Between the 2 programs, near-Earth space accumulated man-made radiation faster than anyone could model. That is what finally forced the issue. On July 25, 1963, President Kennedy and Premier Khrushchev signed the Limited Nuclear Test Ban Treaty, permanently banning nuclear detonations in the atmosphere and in space. An entire category of experimental physics, what actually happens when a multi-megaton weapon detonates above the atmosphere, was therefore run exactly once by the United States and a handful of times by the Soviets, then legally closed for good. No scientist alive today, however curious, is permitted to run that experiment again. There is something almost strange about how public that test was. An entire ocean's worth of people watched the sky turn green in real time, with newspapers covering it the next morning. A very different kind of decision, made much more quietly decades later, involved two of the most promising places in the solar system to search for life, and instead of testing something new there, NASA chose to destroy the only two machines that had ever gotten close. Number 7. Europa and Enceladus's hidden oceans. On September 21st, 2003, after 14 years in space, NASA deliberately flew its own Galileo spacecraft into Jupiter at more than 100,000 miles per hour, tearing it apart in the planet's atmosphere on purpose. Galileo had not failed. It had succeeded almost too well. During its mission, the spacecraft gathered strong evidence that Jupiter's moon Europa hides a liquid water ocean beneath its icy crust, a discovery that instantly made Europa one of the most promising places in the solar system to search for life. But Galileo was also running out of the fuel it needed to control its own trajectory. An uncontrolled spacecraft, carrying whatever terrestrial microbes had hitched a ride from Earth, could not be guaranteed to avoid crashing into that same ocean at some unknown point in the future. NASA's own planetary protection rules, and the international treaties built on them, left exactly one acceptable outcome. Rather than risk contaminating the ocean Galileo itself had just found, NASA destroyed the spacecraft that found it. 14 years later, NASA made an almost identical decision for an almost identical reason. Cassini spent 13 years orbiting Saturn, and during that time it flew directly through the icy plumes erupting from Enceladus, tasting water and organic molecules straight from a moon nobody expected to have geysers at all. Once Cassini's fuel ran low, the same logic applied. An uncontrolled spacecraft could eventually crash into Enceladus, or into Titan, and contaminate a moon whose ocean might already support something alive. Over 5 months in 2017, engineers steered Cassini through 22 increasingly close dives between Saturn and its rings, in a campaign NASA called the Grand Finale, before deliberately flying the spacecraft into Saturn's atmosphere on September 15th and letting it burn up like a meteor. If this list has been worth your attention so far, subscribing helps, because the next entry asks whether some things in dark space might be hidden from us for reasons no policy can override. Picking back up with Cassini specifically, the mission had never been sterilized to the standard required for a spacecraft that might contact a potentially habitable world, because in 1997, when it launched, nobody knew Enceladus had an ocean or that Titan's chemistry was that complex. Cassini's own science team made those discoveries mid-mission, and having made them, NASA was bound by its own guidelines, and by the same COSPAR framework used at Mars, to ensure an uncontrolled Cassini could never reach either moon. The rule did not end with Cassini. NASA launched a new spacecraft, Europa Clipper, in October of 2024, built specifically to study the ocean. Galileo first glimpsed, and its planetary protection requirement is written as an actual number. The mission must keep the probability of ever introducing a single viable microbe into Europa's ocean below 1 in 10,000 for the entire mission, and engineers estimated the spacecraft carried fewer than 350,000 bacterial spores at launch after extensive cleaning, a figure they were required to calculate and defend before NASA would approve the flight at all. 2 of the most valuable machines humanity had ever built were destroyed, deliberately and on schedule, specifically to protect the darkness of 2 moons nobody had even confirmed could support life when either mission began. That is a strange kind of forbidden. Nobody passed a law that said, "Do not touch Europa or Enceladus." Scientists simply decided the risk of what might be alive in that darkness outweighed the value of the machines that found it. Not every hidden thing in dark space is protected by a decision like that one. Some things may be hidden by nature itself, permanently, whether anyone decides to protect them or not. Number 8. Cosmic censorship. In 1969, physicist Roger Penrose asked a question that sounds almost absurd until it is explained properly. Does the universe censor itself? The specific problem Penrose identified concerns what mathematicians call a naked singularity, a point of infinite density that, unlike the singularity hidden at the center of an ordinary black hole, would sit exposed to the rest of the universe, with no event horizon around it to hide what is happening there. An ordinary black hole's singularity is sealed inside a boundary nothing can cross back out of, which is exactly why nobody can ever observe it directly. A naked singularity would have no such boundary. Whatever bizarre physics happens at a point of infinite density would be visible, in principle, to anyone looking at it from a safe distance. Penrose proposed what became known as the cosmic censorship conjecture, arguing that some fundamental rule of physics, a cosmic censor of sorts, forbids naked singularities from ever forming in a universe that behaves the way ours does. Every black hole, the conjecture holds, must clothe its singularity inside an event horizon, keeping the rest of the universe safely separated from a point where the ordinary laws of cause and effect stop making sense. What comes next is the part that still does not have an answer. More than 50 years after Penrose first asked the question, the cosmic censorship conjecture remains unproven. Physicists, including Penrose himself, Stephen Hawking, Robert Wald, and Werner Israel, have all called it one of the most important open problems in mathematical physics, and entire careers have been spent trying to prove it, or to find the exception that would break it. Two of the most sophisticated instruments ever built have already tried to test it indirectly. In 2019, the Event Horizon Telescope produced the first actual image of a black hole, the supermassive giant at the center of the galaxy M87, by combining radio dishes spread across the entire planet into a single virtual telescope the size of Earth. 2 years later, physicists, using the LIGO gravitational wave detector, examined the aftermath of a black hole merger and produced one of the first direct observational confirmations of how an event horizon is supposed to behave. Neither result disproves a naked singularity. Both results are consistent with cosmic censorship holding exactly as Penrose predicted, which is itself unsettling, because it means the universe keeps behaving as though something really is enforcing the rule. Here is the detail that makes this restriction different from every other one on this list. Nobody passed a law forbidding scientists from observing a black hole's interior. No court, no treaty, no funding committee ever voted on it. If the physics holds, and every observation so far says it does, then the interior of every black hole in the observable universe is permanently forbidden territory. Not because any human authority said so, but because nothing that crosses an event horizon can ever send information back out to tell anyone what it found. That is restriction by physics itself, the deepest and strangest version on this entire list. It applies equally to every scientist who has ever lived and everyone who ever will, with no appeal process and no exception granted for genuine curiosity. An unproven conjecture about the darkest objects in the universe is one kind of forbidden question. A single object dark space actually showed us, in plain view, turned out to carry a very different kind of restriction, the professional kind. Number 9. Oumuamua. In October of 2017, astronomers detected something moving through the solar system that had never originated within it. They named it 1I/Oumuamua, the first confirmed interstellar object ever detected, a visitor from another star system passing through on its way back out into the dark it came from. What follows is the part that still does not fully make sense. Telescope measurements showed the object was extremely elongated, at least 7 times longer than it was wide, shaped like a cigar tumbling end over end through the dark. As it left the solar system, it accelerated, speeding up in a way gravity alone could not explain. Comets sometimes do that, when trapped ice boils off and pushes them like a small rocket thruster. But Oumuamua showed no visible outgassing at all, no tail, no cloud of debris, nothing a telescope could identify as the cause. Harvard astronomer Avi Loeb, along with his co-author Shmuel Bialy, examined that gap between the evidence and the explanation and published a paper in late 2018 proposing something almost nobody in his field wanted to hear, stated aloud, that the acceleration was consistent with an artificial light sail. Loeb calculated the sail would need to measure roughly 20 meters across to match the data, thin enough and light enough to be pushed by sunlight pressure alone, a technology, not a natural object. The response from his colleagues had less to do with the physics than with the subject itself. Ohio State astrophysicist Paul Sutter wrote publicly that Loeb's argument insults honest scientific inquiry, and he was not alone. Loeb himself has said the rejection came down to the topic, not the data. Suggesting alien technology, in his field, is close to career suicide, no matter how carefully the paper is worded or how real the anomaly actually is. That response, looking back, was either remarkably brave or remarkably reckless, depending entirely on who is asked, and that is exactly the point. An entire scientific establishment had spent decades trying to separate the legitimate search for other intelligence from the stigma of flying saucer conspiracy theories. Then one tenured Harvard professor raised a genuinely unexplained anomaly, followed the evidence exactly where it led, and was treated as though he had set the whole effort back a generation. Loeb did not withdraw quietly either. In July of 2021, after emailing NASA with a proposal for a dedicated scientific search and receiving no response, he started the project himself. He called it the Galileo Project, funded entirely through private donations, and it has since grown to include more than 100 scientists worldwide, building unclassified sensor systems specifically to search for more objects like Oumuamua, and to study any unexplained phenomena in the sky, using hard data instead of anecdote. Whether or not Oumuamua turns out to be anything more than an unusual rock, the dispute over whether scientists were even permitted to ask the question in public proved to be the more revealing story. For a while, it appeared Oumuamua was the biggest forbidden question on this list. One object, one scientist, one very public professional cost. That was not the real one. The real one has been sitting in plain sight for decades, in something scientists have been able to do this entire time, and have mostly, deliberately, chosen not to. Number 10. The METI moratorium. Right now, today, any radio observatory on Earth with enough power could aim a dish at a nearby star system and deliberately transmit a signal, on purpose, designed to be understood, and nothing in international law stops it. No treaty bans it, no agency must approve it, and humanity has already done it once. On November 16, 1974, Carl Sagan and Frank Drake beamed a message from the Arecibo Observatory in Puerto Rico straight at a star cluster 25,000 light-years away. A string of over 1,600 binary digits describing human numbers, chemistry, the solar system, and a crude sketch of ourselves. Nobody voted on that transmission either. 2 scientists decided to send it, and they did. That practice has a name, METI, Messaging Extraterrestrial Intelligence, sometimes called Active SETI. For years, a serious group of scientists, not fringe voices, has tried to stop it before anyone runs it at real power. Researcher Kelly Smith and others have pushed for a formal international moratorium, hosted publicly through a statement out of the SETI at-home project at Berkeley, arguing that beaming Earth's location into the galaxy without global consent amounts to a mass experiment run on every person on the planet who never agreed to it. What nobody can answer is what happens if that transmission actually receives a reply. Nobody knows whether contact would be the best thing that ever happened to this species or the last thing that ever happens to it, and the scientists pushing for a moratorium do not want to find out by accident, on a timeline nobody voted on. But the commonly held version, that staying quiet keeps humanity hidden, is not the full picture either. SETI Institute astronomer Seth Shostak has argued for years that the moratorium debate may already be pointless, because Earth has been leaking radar and broadcast signals into space for the better part of a century. Any civilization close enough and technically capable enough to notice was probably capable of finding Earth before anyone ever debated a moratorium at all. There is a real chance the line the moratorium tries to hold has already been crossed, decades ago, by a television broadcast or a military radar sweep nobody thought twice about at the time. That disagreement has never actually been settled, which is the part that lingers longest. There is no vote scheduled. No UN resolution like the one debated over weapons in orbit. No treaty like the one that closed off nuclear testing in space. Only 2 camps of serious scientists who fundamentally disagree about whether humanity should introduce itself to the universe, and in the absence of an answer, the default has been silence, not because anyone decided silence was safest, but because nobody with the authority to decide has ever actually been asked. The real question was never whether something is listening out there. It is whether humanity is actually ready for it to answer back. 10 restrictions made this list, from a silent zone on the moon to the hidden ocean of a moon nobody was allowed to touch. Every one of them came down to the same fear, that some knowledge changes what happens the moment someone goes looking for it. Tell me where you're watching this from, and subscribe for more.